Okay, I want you to turn to your book, page 308. What is a mole? Now, we talked a little bit about moles yesterday. Am I correct? Not the mole on your face. All right, so this is going to be page 308. I didn't talk at all yesterday about what a mole is. Oh, no, because we had the Spalding girl here, didn't we? That's right. See, you all did something different than the other classes, so I'm a little off. All right, well then I'll spare you all the cheesy video at the beginning of the chapter. You're welcome.
You know, we could just copy down the layout today.
We could, but the other classes had to do it for homework, so they wouldn't be happy with me. They'd say I was being unfair.
Yes, we don't have to know about it.
Oh, well, word gets out around here. I know how that works.
Yeah, she's recording, so.
I am recording. So, what is a mole? So,
We can make your own.
yeah, well, I hope. I haven't recorded since last year, I think.
Hello.
Hello, friends.
Where's the microphone?
Well, it's on the computer, so I don't know how loud. Last year, my desk was set up right by my smartboard, so when I talked, I was close to my computer. But no, this year, my computer's way over there, so I really don't know how else.
Please send help. If you're watching this, it's too late.
All right. 6.02. Except I need to remember to use my smartboard because they can't see what I write on the whiteboard.
But you see what you write on?
When I do this kind of recording, it records what I write on the smartboard.
So it doesn't record your face.
No. They aren't going to learn anything looking at my face. Okay. So. All right. 6.02 to the 23rd. This is the amounts in a mole. The amounts of atoms, that is. Amount of atoms. It could be the amount of molecules or particles in one mole. That number. And we call this Avogadro's number. Like avocado, but Avogadro. This is Avogadro, and this is probably one of your vocab words. I haven't looked more closely at what your vocab is, but that should be one of your vocab words. You need to know what Avogadro's number is. And so 1 year I had my students do an assignment. We used to do these daily journals, and yeah, you all haven't had to do that, but 1 year I had my students all do daily journals, but we really didn't do them every day. But one assignment was they had to report on October 23rd, on 10/23, what they did at 6:02 a.m. and at 6:02 p.m. Is that your birthday? Okay, well, you have something in common with Avogadro's number then. Yeah, so I wanted those numbers to really stick in their head. So yeah, on the date 10/23, I had them write what they did at 6:02 a.m. and what they were doing at 6:02 p.m. And so in my old book, they used to introduce this topic around October. So some schools will celebrate, or chemistry class will celebrate Mole Day on 10/23 and have a big celebration for Mole Day.
Oh.
But yeah, we missed that.
We celebrate my birthday with a mole.
That'd be cute, like.
So this book introduces the mole much later than my last book. All right, so if you follow along in your book, it talks about how a dozen represents 12. So a mole represents times 10 to the 23rd. So it's a very large number. Times 10 to the 23rd. What, 6.02 times 10, what would that be? 60.2. What would 6.02 times 10 to the second be? 602. So imagine what 6.02 times 10 to the 23rd is. You're going to move that decimal to the right 23 times and fill in with zeros. It's a very large number. So why is the number so big? Why is this number important? Why is it so big? Well, for chemists to quantify pure substances or atoms or molecules, they need a very large amount, like 6.02 times 10 to the 23rd, because atoms are so tiny. You know, you can't see atoms. So to get them to a quantifiable amount, we need this many, and that's what makes up a mole. A mole is like, it's the same as the analogy is like a dozen is to 12, a mole is the 6.02 times 10 to the 23rd. And so when chemists are in the lab, or scientists, you know, like you wouldn't ask your mom to pick up 12 eggs from the grocery, you'd say, can you get me a dozen eggs, or a half dozen? So chemists weigh out quantities in the amount of moles, just as you would, you know, count eggs in dozens. They weigh out particles or atoms in moles.
So moles is a unit, like liter or?
Yes, mole is a unit for the amount of atoms or particles or molecules. All right, so, and we have this word, this term representative particle. Okay, representative particle, it refers to, it could be atoms. If you need to weigh out a mole of carbon, you got carbon atoms. If you need to weigh out a mole of bromine, I want you to remember, go back to the Brinkelhoff element. Bromine by itself, what's so special about that?
I don't know.
Remember the Brinkelhoff element?
Or they combine with each other?
They exist diatomically, meaning there's two atoms. If bromine's by itself, it's represented as bromine 2. So, remember your Brinkelhoff elements. I'm going to bring this up again. They all exist diatomically. So, these are now molecules. So, a representative unit of bromine would be a molecule of bromine. It's Br2. A representative unit of, here's another example, H12 or SO2. These are molecular compounds. So then you could measure out a mole of water, or you could measure out a mole of sulfur dioxide. These are, so representative particles could mean single atoms. They could refer to molecular compounds. They could refer to diatomic molecules, okay? So far, your vocab here, you've got mole, Avogadro's number, and representative particle. All right, so we're going to get into some math. Okay, so let's get into some math. We're going to be doing lots of conversions in this chapter. So, a problem like, this is page 309, sample problem 10.2. Let's do this one. So it says, and some of these problems will give you information you don't need to do anything with. It's just for your information. So magnesium is a light metal used in the manufacture of aircraft, automobile wheels, and tools. That's just information. You don't need to do anything with that. How many moles of magnesium is 1.25 times 10 to the 23rd of magnesium? All right. How many moles of magnesium is 1.25 times 10 to the 23rd atoms of magnesium? I wonder if I can copy and paste this on my smartphone. I bet I can't. Okay, when you attack these types of conversion problems, list your knowns and unknowns. So what are your givens? What are they giving you in the problem? What information did they give you numerically? Information that you could use, not the useless information at the beginning. 1.25 times 10 to the 23rd atoms. Okay, we're going to do some dimensional analysis here. And then, what do they ask you to solve for? What's the question asking? How many moles? So we're converting from atoms to moles. Our desired unit is moles, and we abbreviate moles by MOL. So the abbreviation for mole is MOL. So you'll see that. So we got to use Avogadro's number in this. We know that in Avogadro's number, there's 6.02 times 10 to the 23rd atoms in 1 mole. Okay, that's our conversion factor. Let me write that up here. This could be atoms, molecules, or particles in 1 mole. This is our conversion factor. So, are we going to put this number on the top or the bottom? Why are we going to put it on the bottom?
Because you have to divide it to find out how many.
Well, atoms is here, so you want the atoms to be on the bottom to cancel. So our 6.02 times 10 to the 23rd will go on the bottom, and that's per 1 mole. So atoms cancels, and your desired unit should be left on the top uncanceled, which is the case here. So pull out your calculator, and I'm going to put my TI right here. Okay, so let's remember how to put our calculators in scientific mode. This is really important. You don't want to mess up because it's not punching in something right on the calculator. So, we had 1.25 times 10 to the 23rd. Let's remember how we do this. 1.25, we have to use our EE button. Remember, that's the same thing as times 10. So, if we find our EE button, that's above the comma. So, to use that, you have to push second and then comma. And then the exponent that we need is 23. And now we're ready to divide. You just hit divide by 6.02 EE, so second comma, 23. And now you're ready to hit enter, and that is your answer. So let's look. So look at all these numbers. How many sig figs do we need to report this to? 3 sig figs. So we've got this long answer up here, 2.076419, blah, blah, blah. We only need to go out to the 2.07. That's going to round up because the number to the right to the 7 is, the right of the 7 is greater than 5 or greater. So it's going to be 2.08 times 10 to the negative first.
Could you just take 1.25 divided by 6.02 and go down?
You could. Because we were saying exponents, so you have to actually remember, if you could subtract, because when you are dividing with exponents and the exponents are the same, you subtract. You can remember how to do this. So 2.08 times 10 to the negative 1, what's that the same number as?
0.208.
Yeah. But you can keep it in scientific notation if you want. Because if you're in scientific mode, it's going to give you a number with this scientific notation. Okay, so let's do another problem like this. I think you have to go to mode.
You go to mode, and it's like regular.
Okay, so let's scroll down. And let's do number 3 together. Number 3 says how many moles is 2.80 times 10 to the 24th atoms of silicon? How many moles is 2.80 times 10 to the 24th atoms of silicon? So what's our given in this? What's the problem giving you? And what are we solving for? Moles. So you're going to do this just like the one we just did. And so where are you going to put Avogadro's number? On the bottom. Anybody get an answer? Did you get it? So how many significant figures do we need to take it to? What's our answer? All right, and then go ahead and do number 4. How many moles is 2.17 times 10 to the 23rd? Representative particles of bromine. So what do you got to do here? This is different. What's special about bromine? You know, I'll take that back. We're not there yet. You don't have to do anything different on this. Scratch that. I'm thinking I'm jumping ahead.
How come in the last one there was like no to
Probably it just, that's how it worked out. If you took, did you do it in a calculator?
No, but mine gave me to the 46.
It gave you what?
E to the 46.
Let me see how you punched it in on your calculator. You punched something in wrong. Oh, don't put the times there. When you do the EE button, you don't have to use the times. That will mess you up. After this one, and then I'll give you all some homework problems to do. 2.17 times 10 to the
So I'm screwed up in math. What?
What you all get? That's what I, what'd you do there, Audrey? This is moles of BR2.
Can you do the babysitting something?
Say that again, Casey.
Could you do it like Bruce
3.60 times 10.
You could put 3.60 times 10 to the negative 1, yeah. Exactly. Yeah, if you got 3.60 times 10 to the negative 1, that's the answer.
Will you take either one?
Yeah, I'll take 3.60 times 10 to the negative 1. Yeah, definitely, it's the same thing. All right, so I've got some problems that are very similar to this. And you all will have the remainder of the time. Now on this one, don't do 1B. All right, ladies, there's a couple on here where it gives you moles and you have to convert to atoms. So you're going to flip-flop things just slightly.
You multiply by 6.02 times 10 is 23.
Right. So don't do 1B, okay? When I give you this, don't do 1B. 1B, scratch that out. I tell you what, I've only got 2 more copies left. Will somebody go down and make me some copies for Mrs. Needham? Because I need some more copies. Who wants to? I don't care. Okay, Bree, will you give me mine? Okay, X's Needham to make me 5 copies of this. Thanks.
So wait, when you have to,
Here's one, if you all want to take a picture of it to get started.
when you have to, when it gives you moles, then that, what do you do with that?
So
We learned
then,
this last year.
yeah, if it
This guy
gives you,
didn't teach me well.
if it gives you moles, you're gonna start out with your moles on top, and then you're gonna have the 1 mole down at the bottom and Avogadro's number at the top.
Okay.
You're gonna flip-flop Avogadro's number,
6.02 divided by whatever it is.
you're gonna multiply. If your 6.02 is on the top, because atoms always stays with the 6.02. So you're gonna want atoms on the top, because that's the desired unit for the answer. Yes.
I have one, but I don't have it.
Yes. So on this one, your EE button's right there. And you just press it. You don't have to do a second or anything. You're welcome. Yeah, make sure you put the right 6 We're going back to 6 again.
So even if you had 6.2.
Wouldn't the lower SI too? Because it's silk.
No, that's not a wrinkle hawk. That's not a wrinkle hawk. All right, that's what you have to do tomorrow on the board.
No one gives you the animal.